Okay, mergeSort. mergeSort sort an array by divide and conquer. So in order to sort this array, we first divide it into two halves, the left half and the right half. In order to find the dividing point, we use this formula. In this example, we have a size 7 array. The low index is 0, high index is 6. 6 minus 0 is 6. 6 over 2 equals 3. 3 plus 0 equals 3. So index 3 is the dividing point. 0, 1, 2, 3. This is the left half. Now, in order to sort this left half, we further divide the subarray into two halves. Apply the same formula. We find the index is 1. So midpoint is 1. We get the left half. In order to sort this, we further divide this into two halves. The left half is 3. We try to divide 3. There is nothing to divide. We are done with the divide. Then we handle this half. 2, we try to divide 2, nothing to divide. So what left is merge. We merge 3 and a 2. In order to do that, we need the 8 of an auxiliary array with the same size, 7. And we copy 3 to index 0 of the auxiliary array. And we copy 2 into index 1 of the auxiliary array. And imagine this is left half and right half. Then we compare 2 with 3. 2 is smaller, so we copy 2 back to the original index 0. Original arrays index 0. And we copy 3 to original arrays index 1. And we're done with the merge, left to right. Now we handle this. Again, let's divide. We apply the same formula. We find the left is 4, the right is 1. 4 cannot be divided anymore. We're done with divide. Then 1 cannot be divided anymore. Then we merge. In order to merge, we copy 4 into the auxiliary arrays. Index 2, we copy 1 into auxiliary arrays. Index 3. And we imagine there is a dividing point between the left half and the right half. It's imaginary. Okay. So we compare left and right. One is smaller. So let's copy it back to original arrays, index 2. And whatever left on the left half, we copy it back to original arrays, index 3. And we're done with the merge. Next, we need to merge this and this. Again, we copy those two elements into auxiliary array corresponding. Index, we copy 1 and 4 to auxiliary array. Imagine there is a dividing point. Then let's compare the first element of the right half and the left half. 1 is smaller, so we put it back to original arrays, index 0. And we compare 2 with 4. 4 is smaller, so we put it back. And 3 with 4, 3 is smaller. Then whatever left on the right half, we copy it back. And we just merge those two subarrays. So we're done with the left half. Now let's deal with the right half. Here first, let's divide and conquer. Let's calculate the dividing point. The low is 0, 1, 2, 3, 4. Low is 4. High is 6. So 6 minus 4 equal 2. 2 over 2 equal 1. 1 plus 2. 1 plus 4 equal 5. So middle point is 5, which is 0, 1, 2, 3, 4, 5. And this is our left half. And we can further divide the left half and the right half. So 6 cannot be divided anymore, we are done. Now 8 cannot be divided anymore, we are done. Now let's merge. Let's copy 6 to the auxiliary array, index 4, and 5 to the auxiliary array, index 5, 8 to the index 5. Okay, imagine there's a dividing point. Let's compare 6 and 8. 6 is smaller, so we put it back to the original array, index 4. Whatever left on the right half, we copy it back to original array, index 5. Now, whatever left, 0. Let's copy it 0. We cannot divide anymore, so we are done. Let's merge. We copy 6 and 8 to the auxiliary array, and copy 0 there as well. Imagine there is a dividing point. Okay, 0 compared with 6 and 8. 0 is the smallest. So we put it back to original array. And we exhausted the right half. So we copy the left half back to the original array without comparison. Now we're done sorting the right half. Let's merge the sorted array into a bigger array. So let's copy this into the auxiliary array. And copy this to the auxiliary array. And imagine here's the dividing point. Okay, let's compare the first element from the right half with the first element with the left half. 0 is smaller, so we put into the original arrays, index 0. Now we compare 1 with 6. 1 is smaller, so we put it back into the original array, index 1, and then compare 2 with 6. 2 is smaller, so we copy it back to original array. 3 is smaller than 6, we copy it. 4 is smaller than 6, we copy the smaller. Now whatever left on the right half, we copy back to the original array without further comparison, and we are done. Now let's analyze how many compare and how many array access we need to accomplish this sorting. So in order to merge those two subarrays, we need to do at least in the basic scenario, we need to do 1/2 half n comparison, right? And in the worst case, we need to do n comparison. So for merging these, we also need to do from n/2 to n comparison. For merging these, we do same amount of comparison. So for each level of merge, we do from n/2 to n comparison. So how many levels we have? We have logN levels. So that's our answer. The total comparison is from n-logn/2 to n-logn. Array access. For each level of merge, we first need to copy the elements into the auxiliary array. Copy need to n. And later, we need to copy the elements back to the original array. The copy back need another 2n array access. And we need to do n comparison. So again, comparison need 2n array access. This is a total array access for each merge. For each level of merge, totally we have logN level. So we got 6n logN array access. That's cost. Now we understand algorithm. Let's write a program. Okay, in order to merge, we need an auxiliary array. Let's create it. Next, let's copy the original array into the auxiliary array. We only need to concern about the range from low to high. And let's copy. Once we copied it, we need to copy it back in order to merge it. And before we do that, we need to mark the starting point of the left half, which is a low, and the starting point of the right half, which is a midpoint plus 1. This is a starting index. Then there is a 4 scenarios. If we exhausted the left half, then we just copy from the right half without a comparison. Else, if we exhausted the right half, then we just copy from the left half without further comparison. In the normal case, we copy the smaller one of the halves. In this case, we copy j because j is smaller. Otherwise, we copy I. Now we're done with the merge. And then let's do the sort. Okay, private. The first thing we do is we need to calculate dividing point. Once we have the dividing point, the next thing is we need to code the exiting point. So if no above high, we know this is a one element array. We don't need to do any further dividing, so we are done. Otherwise, we recursively call itself left half, sort of the left half, then we sort the right half. Then we merge. And we're done with sort. Next is finally passing our original array. And sort it. The overloaded sort method sort it by side effect. So that's passing the lower index and a higher index. Okay. Let's test it. Okay. This have to be static. And we are done. And this is a result. We sorted the integer array into increasing order with merge sort. The cost is NlogN. Array of cells is 6 NlogN.